Hello everyone, welcome to my channel. In this video, I will explain about radial basis function. Okay, so one of the important question in machine learning. So let us discuss about the radial basis function. So before going to discuss about the radial function, we'll discuss some topic which is called as a linearly separable. Data can be either linearly separable or non-linearly separable. So remember, the data can be two types. First one is the linear separable, or else second one is the non-linearly separable. Single layer perceptron can be used for classifying linearly separable data. Okay, so what is the purpose of single layer perceptron? It is used for classifying the linearly separable data. So when we discuss about the radial basis function, we must know the basics of what is the meaning of linearly separable and what is the meaning of non-linearly separable. So when we use this linearly separable, we use something called as a single layer perceptron. Okay, so more we'll discuss what is the meaning of linearly separable, what is the meaning of non-linearly separable here. You observe, so in this linearly separable means a decision boundary that separates two classes. Most important point. So what is the meaning of linearly separable? A decision boundary that separates two classes. So this is called as a linearly separable. Okay, so when you draw the line between two classes, that is called as linearly separable. Not linearly separable means no linear decision boundary that separate two classes. Okay, so when you have not linearly separable, there is a no decision boundary. Okay, so you observe what is the example of linearly separable. So the example for linearly separable is, you observe here, this is called as a line. This is nothing but decision boundary line. So in this, what is going to be happened? This is the upper part of decision boundary. This is the lower part of decision boundary. So when it comes to upper part, these are called as circles. When it comes to lower part, these are called as, let us say, squares. So what is going to be happen? This decision boundary. Okay, so this decision boundary divides this data into two types. Those are called as, first one is the circles and the second one is the squares. So this is called as decision boundary. Okay, so if you draw the line between two classes, this is called as linearly separable. But when it comes to non-linearly separable, so these two are examples for non-linear separable, because here upper decision boundary, there is something called as a square added in addition to these circles. Okay, so in the down boundary also added circle for squares. So this is a not linear, but we can say non-linear. So here also same. In this, there is a line is there, but it contains combination of circles and squares, and it also combination of circles and squares. Okay, so now let us going forward. Multi-line perceptron used for a non-linear separable data. Okay, so we discussed about the what is the meaning of separable, what is the meaning of non-linear separable. So when it comes to linearly separable, we are using something called as here single layer perceptron. But when it comes to multi-layer, we are using non-linear non-separable data. Okay, so non-linearly separable data. So please remember all of you. Now we'll enter into our topic. This is called as a radial basis function. So what is the meaning of radial basis function? Radial basis function is a type of multi-layer perceptron. Okay, so it is a type of multi-layer perceptron. Please remember all of you, which input layer, one input layer, one output layer with one strict hidden layer. Okay, so you observe what is the meaning of this radial basis. Here it contains input layer as well as one output layer with strictly one hidden layer. So remember all of you, when it contains only one hidden layer, we can say that is called as radial basis function. So remember all of you, in this diagram, if you see here, So these are x1, x2, xn, these are called as inputs, and yn, this is called as output. So in this we have only one hidden layer. So here x1, x2, xn are inputs, yn is output, but this is called as only one hidden layer is there. So we can say this is called as radial basis function. Okay, now you see the hidden layer uses a nonlinear radial basis function. Yes, because we are using multi-layer perceptron. So the hidden layer uses a nonlinear radial basis function as a activation function which converts input parameters into high dimension space, which is then fed to network to linearly separate the problem. Okay, so in this what is going to be happen when the data is non-linear? So we are going to use the radial basis function. By using radial basis function, we are going to convert that data into linearly separable or linearly separate problem. Okay, so now we'll see what are the uses of radial basis function. So remember all of you, one of the most important slide, radial basis function is used for interpolation. Second one is the function approximation, and third one is the time series prediction. Fourth one is the classification. Fifth one is the system control, and last one is the speech recognition. So we are using in this all 6 aspects about this radial basis function. So everyone should remember these are called as uses of radial basis function. Okay, now you observe here typical radial basis function are, so you observe typical radial basis function are Gaussian radial basis function which monotonically decreases distance from the center. So remember actually there are 2 types of radial basis function. First one is called as Gaussian and second one is called as multi-quadratic. But when it comes to Gaussian, how to find this formula? You can see Gaussian radial basis function which monotonically decreases distance from the center. So it is going to decrease the distance here. Okay, so what the formula is, h of x is equal to e power minus x minus c power square by r square. Here x is the center and r is also called as a radius. Okay, so but when it comes to multi-quadratic radial basis function, we are using the formula. The formula is called as h of x is equal to square root of r square plus x minus c whole square by r. Okay, now we'll see the differences between Gaussian radial basis function and multi-quadratic radial basis function. So please remember all of you, this Gaussian radial base network is this is called as a local response, but when it comes to multi-quadratic, this is called as a global. So in Gaussian radial basis function, we get bell-shaped curve. Okay, but when it comes to multi-quadratic, we are going to have something like a hyperbolic. Okay, so what is the purpose of this Gaussian radial basis function? We are using for classification and clustering. But when it comes to multi-quadratic radial basis function, we are using interpolation, surface fitting. So these are called as applications of Gaussian and multi-quadratic. So last one, the application of this Gaussian, this is very simple, but when it comes to multi-quadratic, it is a little bit complex. Okay, now we'll see a radial basis function algorithm. So what is algorithm? You observe here, the algorithm is inputs are here, let us say input vector is x1 to xn, so output is yn. Assign random weights for every connection from the hidden layer to output layer in the network. The range could be -1 to +1. So always you remember, we are going to assign to the inputs. So when you have given some inputs, those inputs will be assigned some weights. So we are going to multiply inputs with weights. That information will send to activation function. Finally we get some output in the output layer. Now remember all of you, there are two things you need to remember. So that is called as forward phase and backward phase. So in radial basis function, there are two phases are there. First one is a forward phase, which is going from input, hidden, output. When it comes to backward, so here output as well as hidden and input. Now you see in the step 1, calculate the input and output in the input layer. Okay, so input layer is a direct transformation function where output layer is output of the node is equal to the input. So input at node I, that is equal to I of I is equal to x of I. So xi nothing but input received at node I. Okay, so first we are going to calculate the input and output. Second step, for each node j in the hidden layer, find the center or receptor C and variance R. So define the hidden layer with neurons, which is with Gaussian RBF whose output is Hij is equal to e power minus x minus c whole square by r square. So by using this one, we are going to find out the distance. Okay, so here what is x, what is ci, what is cj, what is r. So x is the input, cj is the center and r is the radius. Okay, now what is the meaning of this x minus cj whole square? This is equal to applying Euclidean distance measure between x and cj. So in the step 3, you observe for each node k in the output layer, compute the linear weighted sum of output of each neuron k from the hidden layer neurons j. So that formula is equal to fkx is equal to sigma j is equal to 1 power m. So wjk hjx. So what is wjk here? This is called as a weight. So hj of x is equal to output of the hidden layer. Okay, so this is called as a this is called as forward phase. So in this, the data can be moved from input, hidden and output. But when it comes to backward phase, so what is the meaning of backward phase? In the backward phase, first we are going to train the input hidden layer using back propagation. So remember all of you, we are going to train the hidden layer using back propagation. Okay, so now update the weights between hidden layer and output layer. So you need to update the weights between hidden layer and output layer, and finally we get the result. So please remember, when there is something called as a forward phase, you are going to send the information through input that will be given to the hidden layer. Finally we get some output. If at all we not satisfied with our output, we need to update the weights, that is called as backward phase. Okay, so now we'll see the advantages of RBF. The advantages are, first one is it handles scattered data. So keyword all of you please remember when it comes to RBF. So we are going to have scattered nothing but bulk data. The data of length is maximum. So it works in high dimensions and flexible modeling. So there the keywords are scattered, high dimension and flexible. But what is the disadvantage of this RBF? High computation cost. Okay, so the cost is very high. Large memory requirement. So we required large memory. So this is all about the RBF radial basis function. Thank you for watching this video. Please subscribe my channel. Thank you one and all.